Hi, this is Sparshan HK presenting a video for our final project for our class Data Structures and Algorithms in Spring 2020. Our final project was an implementation-based project where we explored the differences between Dijkstra's algorithm and the A-star heuristic algorithm by comparing the performance of each algorithm at different situations. Before diving into the details of our project, let us first explain how we landed on this idea. At first, we were both very lost with coming up with an idea that both of us were excited to dedicate our time to for the rest of the semester. Only one thing was clear, that we were both strongly inclined to take the implementation track. After spending a good amount of time on researching interesting areas of data structures and algorithms, we landed on our final idea. The idea for our final project was developed from the moment when our professor, Alice, briefly went over the different performance of pathfinding algorithms from a variety of platforms such as Google Maps and Bing. And this is the moment that was transformed into our final project idea of comparing the performance between Dijkstra's algorithm and the A-star heuristic algorithm. We wanted to represent an actual city or an area that exists in the real world to test our Dijkstra's and A-star algorithm, and the location we chose was Boston, near and dear to our hearts. The dataset used to generate a graphical representation of the streets of Boston and to query their latitude and longitudinal coordinates was from a street sweeping schedule. This dataset contained information about the starting street and the ending street for the sweeping and the distance between them. We also looked at the peak traffic times and the traffic-heavy areas in Boston City and implemented the traffic heuristic accordingly. To get started on the implementation, we went through the data processing step where we converted our dataset into an undirected graph. We stored all the unique streets by numbering them when hashing. You can see the dictionary that contains the unique streets being output in the terminal and a visualization of the graph generated from the dataset. During the data processing step, not only did we generate an undirected graph that represented the streets of Boston, but also queried the latitude and longitudinal coordinates of all the unique streets and saved them for easy access. Our function that implemented Dijkstra's algorithm returns several things. First, it returns the most optimal path from the starting street to the destination street using Dijkstra's algorithm. Second, it returns the most optimal path from the start to the end using the Network X algorithm, which we discovered uses Bellman by default when no other algorithms are specified, so that we can compare Dijkstra's versus Network X's shortest path call. Then it also outputs the estimated total distance using Dijkstra's and Network X's. Finally, it outputs the estimated time of arrival, which accounts for the current time in the traffic, and the runtime of this whole script. Our function that implemented the A-star heuristic algorithm returns similar outputs as to Dijkstra's, only except that the network access component is missing. The outputs include the most optimal path from the start to the end using the A-star heuristic algorithm, the estimated total distance, the estimated time of arrival, and the runtime.
Using the math figures, we can observe that the A-star heuristic algorithm is modifying the shortest path to incorporate the traffic conditions. The heuristic offsets the path so as to avoid the streets that directly cross the city. For our algorithm, it is the streets within a radius of 1 mile of the city. For the particular results that we're showing now, we can observe that the A-star algorithm chooses to set the path around the city as much as possible before entering the heart of the city. If we run our algorithm during the time of the day when there is low traffic, we observe the increasing similarity between the Dijkstra's algorithm and the A-star algorithm, with decreasing traffic. If we consider no traffic conditions, the outputs are identical for both algorithms. As for the runtime of the algorithms, we expected the heuristic algorithm to take a much longer time than Dijkstra's algorithm implementation. In general, the A-star algorithms that we implemented took about an order of magnitude more time relatively. We observed this behavior for both heuristic types. Comparing the two heuristics, which are using Euclidean distance with or without the traffic conditions, we noticed an irregular correlation. In some cases, the traffic conditions would not cause the runtime to change by much, while for others, the runtime is comparable. One explanation for this could be the high traffic streets, which have an effect of being ruled out from the possibility of making the quickest route, which could argue for reducing the total time or even covering the time cost for calculating the traffic conditions on top of that for other streets.
But wait! Before we end this video, thank you for watching, and we really want to thank the teaching team, Alice, Nick, Cassandra, Anisha, and Jane for the semester of DSA amidst the COVID crisis and quarantine. Thank you so much again, and we hope for no corona!